Okay. So good morning, everyone. Thanks for joining. Okay, and I'm Vijender, and I think most of you, if you are coming from meetup groups, know me. Um, so, so today's session, we're going to talk about TableRAG, right? Which is like RAG, on steroids, right? If I may say. So we're basically using agents to kind of advance the basic capabilities of RAG. Okay. So how many of you are already aware of RAG and the underlying architecture? Thumbs up if you already know. You can say thumbs down if you don't know, right? So I get an idea of where we get going from. Uh, okay, Jashwant already knows. Anybody else? You guys, thumbs up, thumbs down. Okay, Maurya, Afan already knows. Okay, good. Shravan knows. Okay, good. Okay, so if you guys know it, then that's great. So today's session is not going to be about me talking about stuff. It's going to be Q&A. Okay, so I'm going to ask you questions, and I want you people to answer. Right, and that's how we build a solution. Okay, because I believe that's the right way to kind of learn. Right. If I just keep on telling stuff, you listen, and after a point in time, you start zoning out, right? And then it helps no one, correct? So way I generally connect my sessions is through Q&A. Okay, so I keep asking questions. So feel free to unmute and speak out. Okay, or if you can't unmute for some reason, then feel free to put it in the chat. Okay, but I would like you guys to participate. Okay, so that's how you kind of challenge yourself and learn. Okay, let's get going. Let me share my screen. I'll open Eraser. Okay. Okay. So let me just share my screen. Okay. Let me know when you can see my screen. Okay. Now, can you all see my screen? Thumbs up, please. Can you see my screen? Okay, great. Okay, perfect. So let's get going, guys. Okay. So I know it's going to be interesting. Okay, if you're paying attention and try to give it your best shot. Okay, if you answers for all of them, don't worry about it. Okay, try to give the best of what you can. That's fine. Okay. What you don't know is a learning. What you already know, you just let us know. Okay. Okay. So let's start with the basic premise, right? Again, before building any software or anything, I think the most important thing is understanding the problem. Correct. So that's what we'll do first. So first thing is, let's say I have a PDF here. Okay. I have a PDF. Okay. And in this PDF, okay. Okay, so I have a PDF here, and I'm going to show you the PDF also. Okay, so like I said, nothing is theoretical, nothing is empirical, right? In what I say. So we start with the real stuff. We look at real code, and we see the real output. Okay, so this is documented the FIFA World Cup. Okay, historical journey. It talks about the early years of the FIFA World Cup. It talks of post-war resurgence. It talks about expanding horizons and illustrative World Cup match results, right? And some match results in the form of various teams, okay, in various years. Okay, so you can see years 1930, 34, 38, 50, and then which countries. So in football, you have something called the home team and away team, correct? So home team means where they come and play at our side. Away team means where we go and play at their side. So Uruguay home team means they're playing in Uruguay, and if Uruguay and Peru are playing, that's a home team. So away means they go play in the other place. So what is the home score, away score, and who's the winner? So again, some results like this, don't worry too much about football, but some data like this. Okay, so now in this document, so let's say I'm interested in learning more about this document, and I don't want to go through this whole document. I know this is a short document, 6 pages or whatever, but let's say this is 300 pages. Obviously, we cannot go through everything, correct? So let's say we're building a chatbot which is going to ask questions from this. Okay, now typically what people do, they'll say, okay, go for a RAG chatbot where you will convert this into chunks and put it into vector embeddings and a vector database and all. Okay. So first question for all of you is it really necessary to use convert this into chunks, vector embeddings, and create a database? Is there no other way, right? Because I will want to challenge you, and I will say there is something called Elasticsearch, right? I'm not sure how many of you know. There's something called Elasticsearch. Okay. It's a very powerful search, distributed search and analytics product, okay, which is already there, which is there for a very long time, okay. Now, what this does is, if I ask a particular query, correct, and all this data is in the database, whatever is there in this PDF, correct. Now it's in the PDF, but I convert it into a database. I put it into database, right, and I ask a query saying, tell me about the again, it says I'm interested in knowing about the first World Cup was held in which year, right? Something like this. So it can pretty much kind of get me some result, right? Because it's a search, it's an exact search, and it'll be able to go and get me the results, correct? But of course, if since I mean, if products like that are already there, what is the real benefit of using RAG, right? Anyone? If you already have products which can fetch a results. Now, Google search is a classic example, right, guys? I'm sure all of you know Google search. You are searching with some natural text, right? So you're saying something like, tell me about the history of, FIFA, right? FIFA World Cup. So you're typing in natural language, correct? And it's giving you results, right? It's giving you links as well. How is it giving you results? How is it giving you these links? Because it's using a similar kind of a search, correct? Now, this kind of a search capability has existed for a very long time, correct? One second.
Hello.
One second. Sorry, guys. Okay. So the point is, Google search has already been able to do this, right? So why do we need RAG? Anyone? Because Google is also able to give us results, right? Of course, it is not giving us like like a concise format, but it's able to give us the links to documents, right? So do we really need RAG, and what is the benefit? Yeah. Okay. Mario, over to you.
Yeah. Am I audible now? Am I audible?
Yeah. Okay. Go to you. Yeah.
Yeah, Elasticsearch. I think. I mean, I don't have a good idea about Elasticsearch, but what I know about Elasticsearch is it searches on the whole data, like it sets on the whole structured data, but it won't make the data into chunks. And if there is a lot of data in a PDF, or if there is a lot of data to handle, it can't scale as a vector DB. That was the benefit. I think that is an edge for vector DB because it stores things in chunks. And when we give a question, we want to match the similarity of the question to a chunk that is in index of the vector DB.
So
I think that would happen.
I'll challenge you. Maria. Elasticsearch is a distributed system which has indexes. Okay. So indexes, your vector DB, what you're talking about is not new, right? It has been there forever, right? In traditional databases, it's been there. So so Elastic is very fast, right? I mean, it will index it. So if you're making a search and show me something, it already indexes all the content and searches within that, right?
Okay.
One second. I think there's somebody who's
sorry again, but the fifth floor, what?
Conference room. Yeah, the conference room, the very first room. The very first room, the conference room. It will be written conference room.
Conference room.
Yeah.
Okay. I see some Eurotech.
One second.
Did I come to the right thing?
No, I think you're on the 4th floor. You need to come to the 5th floor. 5th floor.
No, it says level 5 here. It says level 5. It is level 5. So do I need to come one more floor up?
Yeah, I think so. Yeah.
Conference room, common conference room.
Okay, sorry guys, just one second. Okay, guys, sorry about it. So, actually, I gave some people can join physically also, so it's searching. So the question is, indexing is not a new thing, guys. It's been there forever, right? What they're doing in what you indexes you see in vector DB is just an extension, right? So that's not the thing about it. And it's not that Elastic cannot scale. Elastic can very well scale, right? Because Elastic has been powering the entire ecosystem for years, right? Till you see RAG, what has been happening? Stuff like Elastic only, right? So the thing about RAG is that there are two benefits. One is it's natural language, right? Second thing is it can give you a more precise answer as compared to Elasticsearch. Elasticsearch is like Google, right? What does Google give you? Right? Google will just give you links. It doesn't tell you the exact answer, correct? It will tell you, I think what you're looking for is somewhere here. Go and figure it out from there, correct? Now it's our job to go and figure it out. Now, why do you think people are not using Google anymore? Because ChatGPT is giving you the answers, correct? And which is easier? ChatGPT is much simpler, right? Who wants to go and take the pain of going into all those links, right? So I don't know how about you guys, but nowadays I don't use Google for searches at all, right? Pretty much I use ChatGPT, and I'm sure most of you also do that, right? Because it's simpler. So again, Afan is saying we'll get detailed information according to our previous prompts too. Yeah. Yes, absolutely, right? So it again has text too, correct? Yeah. Okay, Purandar, you want to say something?
Hi, this is Sumant. So yeah,
Yeah.
so that's a change, a name change. But the
Yeah.
thing, I mean, not to contradict about AI, but the thing, I found between ChatGPT versus Google is ChatGPT just gives on what you are trained, etc. Whereas if you go to Google, and click on multiple links, the amount of knowledge you give or the deep dive you give is much more than what you get on ChatGPT. Yeah, is my observation based on my work experience.
No. So the point is, again, if you look at it, right, if ChatGPT, I understand what you're saying, ChatGPT has limited context, but it's not the case, right? Now they've also opened something called MCP and all that, right? So they go and search the web, they don't have enough context. So ChatGPT does it. And making your life easy, right? It's also searching the links and getting the summarized information for you. Right? Have you seen that in ChatGPT? It actually is searching the
I've
web.
seen that, but the amount of knowledge you gain via Google's links is much more than ChatGPT, is what my observation is.
See, end of the day,
Just want to get a rough idea, fine. Now, what is a cat? You want to get, just know about cat, fine. But if you want to go deeper of what it is,
no, I get it.
it is not an answer.
Yeah, no, I get it. See, end of the day, it depends on what you're looking for, right? Most of the
Yes,
times,
exactly.
I want an answer. I want to move on in life. That's it, right?
Yes.
Want to do research again? Yeah, be my guest, right? Yeah. So let's move on. Okay. Now we decide. Okay, let's go for RAG. Okay. Now next question I have for all of you guys is now that we have a document, right, a PDF. I guess traditional RAG says put it into chunks, correct? So chunks is smaller pieces of the PDF, right? So that you can store it somewhere in smaller pieces, and then use these, search in these pieces. Okay. Now these chunks again, the next step is from these chunks you convert into embeddings, right? So anybody can tell me why you need to convert into embeddings and why not directly store them as text by itself? Anyone?
Because it will be easier for the LLM to embed it.
No. Embed what? No. You are doing extra work, right? So why do we want to do vector embeddings from these chunks? Chunks are nothing but, I showed you this PDF, right? This whole PDF. Let's say this paragraph, every paragraph is one chunk. This is one chunk. Okay. Chunk means small piece. Okay. This is one chunk. This is one chunk. Every paragraph is one chunk. So how many? So we'll have so many chunks in this document. Correct. Now, can you tell me why we should do chunks?
For the faster embedding, for doing it faster.
Faster what?
The process of doing the embedding.
Okay.
If they are smaller chunks, it will do more faster.
Okay, yeah, smaller chunks is, I agree. If you have smaller chunks, it's much faster to analyze. But why do we need embeddings? Why not store those smaller chunks into the database and directly search what the user has asked against those? Why should we use embeddings? Anyone?
I think
okay, so we can we have to do embedding for the similarity search.
Correct. That's right. So we do the embeddings because we get the similarity search, because NLP, right? What we are typing in English. Let's say I type a question now. Okay. I type a question. You're saying, tell me about Zinedine Zidane. Okay. And this is my question. Okay. Now, if I want to ask this question, right? The semantic meaning of each word is important in this, right? If you convert with another text, let's say Zinedine. Okay. So let's say again in NLP, you guys know it, right? How I talk about it, bank versus river bank, right? This is a classic example, right? That people say bank versus river bank, correct? So a regular bank will be a bank, but a river bank is a different context. So vector embeddings store the semantic similarity or meaning of each sentence or each word in this sentence. Okay, so if this is your chunk, it stores the semantic meaning of each one of them in the vector space, in three-dimensional or multi-dimensional space, and then this is stored into a vector database like Pinecone. Can someone tell me any other vector databases?
Yeah.
Chroma DB.
Quadrant.
Okay, Quadrant, ChromaDB.
PostgreSQL
No, PostgreSQL is a MySQL, it's a relational database.
with the extension of PG vector.
Okay, with a, you have an extension. Okay, same like MongoDB, right? You're saying, okay.
VV8.
Yeah, okay. So, okay, good. So now that you're working into the vector embeddings over here, has anyone actually seen vector embeddings in any of these vector databases? Actually gone in and seen? Yeah.
Yes.
Anyone seen them?
Yes.
Okay, that's good. Okay, so next thing is probably again I'll also show you. So then you have a user query. Okay, now user query is basically tell me something about Zenit incident. Okay, so that's the query which is out. Okay, now user query also gets chunked. Okay, again pretty much you don't need chunks because the query is not very huge. So we directly go for embeddings of that. Question to you guys: do we need to use the same embedding model that we used above or different? Can it be different?
It has to
have
be
to
the
be the
same.
Okay. So again, you create vector embeddings. That's good. It has to be the same. Okay. Next question. Should this embedding model come from an LLM like Gemini, or can it run in the local through any packages?
Sorry.
Can this embedding model, whatever embedding model you guys are saying, right, which is used in both up and down, should
It need not come from LLM, right?
Okay.
It comes from an encoder. Like
Good. Okay, good. Okay, vector embeddings, and then these embeddings are then searched, in the vector space, correct? And what comes out of that? Hey, is Raghu? Yeah. Yeah. Yes. So what comes out of this embedding? So you basically do the similarity search out of this, and this kind of returns the chunks, correct? Which are similar, right? So how many chunks does it return? Anyone from this vector database?
based upon the chunk size.
The chunk which we have been set the amount.
Okay, the number of chunks that you set, correct?
Yes.
Okay, and what else do you get from the vector DB apart from the number of chunks? So let's say you're saying I set 5 chunks, so I get 5 chunks. Do we get anything else apart from the number of chunks? Any other information about these chunks?
Document ID.
Huh? Or, no, the ID is okay, but are they ordered?
If we use
No,
any
it will,
ranking
no,
algorithm.
it will go to the LLM model again, and it will form it in a meaningful like.
No, it won't go. You're hitting the DB directly, right? So you take the vector embeddings from the user, hit the vector DB, and you get the chunks from the vector DB, correct? Vector DB is giving these chunks, correct? So what all information is considered is there in each chunk, correct? So first of all, you'll get 5 chunks because you said 5. Then you get ordered, right? You get relevance. So each chunk, it gives a score, okay? It tells you what is the relevance of the similarity, okay? And then it will also tell you what is the chunk, exact chunk text, correct? Because if you were dividing this entire PDF, right? So you saw this is one chunk, right? And this is another chunk, let's say, okay? Again, typically it won't be that. And then you have, this is the third chunk, right? And so on. So it will return this entire text because this is the entire chunk that you stored in the vector DB. Got it? So if I search for something like, tell me about the first World Cup, which was held in Uruguay in 1930, then it will give you this chunk, correct? If I tell me about the 12-year hiatus due to World War II, it will give me this chunk. Okay, it will not give you the small text; it will give you the entire paragraph. Correct? Got it? So you get these 3 pieces of information from the vector DB. Then what do? Then we take these chunks, okay, and we give these chunks out to the LLM, right? Right. So you take these chunks out, what you got, these 5 chunks, right, and you give them to the LLM. And what else do we give them? You also give the original user query, right, which comes from here, right? So now the LLM has both the chunks, 5 chunks, okay, and it has the user query, right? And what does it do? It's going to just analyze these 5 chunks and the user query because it now has this entire paragraphs, right? It's going to give you an intelligent answer, correct? It's going to give a response, and this response is what goes back to the user, Cool. Any questions? So that is the role that the LLM plays here, right? LLM doesn't play any role here apart from just taking the chunks, taking the context and returning a response. Cool. Yeah. Any questions here? Then I'll ask my questions. Anybody any questions here?
Will there be any caching layer between the response?
You mean say prior to sending it to the LLM or after sending from the LLM? After the response is got from the LLM?
After the response is prepared by the LLM.
Okay, after the response is prepared by LLM, you want to cache it. You can do it. If your queries are going to be the same, you can always cache them, right? Because every time your suppose user asking the same question, there's no point in hitting the LLM because you'll always get the same chunks, correct? There's no point in hitting the LLM, and you can cache it that way. But you'll have to be careful about your queries, correct? So you can cache your queries to reduce your costs. Yes, you can do that. Or you can also cache your queries if you feel that the queries are semantically similar, correct? So let's say user asks, somebody says, tell me about Zinedine. Somebody just types generally, I mean, most of us, that's what we do, right? We just type Zinedine because we assume that the LLM is smart enough. So we just say Zinedine, that's it. So both of these are pretty much the same, right? Okay, or tell about, okay? If you look at tell about Zinedine and tell me about Zinedine, both are same, right? Pretty much. I mean, you would pretty much get the same kind of information or expect it to, so you can catch them. But the point is you must be reasonably clear in terms of how you figure out what are semantically similar. Otherwise, you might get the previously cached response, which may not be relevant. Okay, so that's one strategy.
You will need how to identify similar response. You need one more block.
Yes, you need. That's what I'm saying. If you want to do that caching, you'll have to put that extra effort, right? But again, if you, at the onset, to keep it simple, you don't have to. I mean, for the purpose of it. So next question I have for you guys is, what is the, again, when I look at this PDF, right? I said this, this is one chunk, right? And this is another chunk, right? But visually I can look at it this way, but I can't define a chunk size based on the paragraphs because I don't know what this document is going to contain, correct? So then what we have to do is identify a chunk size, correct? A particular size. So it can be 2000, 5000, 800, whatever, right? So this particular chunk can, if I say, let's say it's 1000 or 100, it will just stop at 1930, correct? So the next chunk starts at except in 1942 and goes all the way till sport, or maybe it goes all the way till team, correct? Over here, right? And then third chunk can only come from here to here, correct? So can someone tell me what is the trade-off involved in defining the chunk size? What happens if I have a large chunk size, okay, versus a short chunk size? I'm saying very large chunk size, okay, versus a very small. So what is the trade-off involved in very large chunk size, guys? Anyone?
Maybe one of the thing is the context window size.
Yeah. So yeah, context will increase. Yeah. So what's the impact?
If the chunk size is more, the response rate will be like slower.
Like the token count.
Token count will be less. Yeah. So what's the impact of that?
I mean, like cost based on it.
Yeah, first
That's
is
also
cost.
one of the factor, but it might not be the major factor.
Which one cost? You mean cost?
The bigger chunk size, the tokens are more, and then the cost is more.
Correct. Yeah, cost is more. Okay. What else? So typically, if you look at it, right, again, software engineering, pretty much, again, the way I look at it, going forward, people are not going to be valuing you for your coding skills anymore, right? So, people, I don't know if you folks are following me on LinkedIn. I put up a post recently, right? So where I solved a problem which my developer was struggling for 6 hours, right? I solved it in just 15 minutes using prompts. Okay. And the funny part is I don't have a clue about what's there in that code. Okay. So there were 2 files. I know these 2 files are the ones which have code in them. I used to just attach those files. I'll give you the prompt. I just said start from clean. I just gave the prompt in English. He ran it in Claude. He got the response. He did the changes what Claude suggested, and boom, it's done. Okay, 15 minutes. So the thing I want to tell you guys is coding is no longer the differentiator or your moat, right? Nobody's going to value you much for that. They're going to value you for your design skills. Okay. And this is where your design matters, right? So in decisions like this, because if you're building this chatbot, right, and you are one of those guys who just saw on some YouTube video that chunk size should be 5,000. So you also went ahead with 5,000. Your costs are going to rise through the roof, right? Because imagine you are hitting 5 chunks here, and each chunk is 5,000. So that's basically what is the chunk size, the total number of words. Let's say it's 25,000. Okay. So you are hitting an LLM with 25,000 here, right? And can someone tell me how LLMs charge you? How do LLMs charge you?
Based on tokens on.
Tokens, but is it input tokens, output tokens? What is it?
Yeah, input have some cost and output have some cost. Output will have more cost.
Correct. So input, so LLMs charge you on the basis of tokens, correct? So these chunks, right? Chunks consist of words, and words are converted into tokens. Okay. So it's not that directly the LLMs will charge you for the words. So basically you have words, basically you have chunks, right? Chunks will consist of words. Words will be converted into tokens. Okay. And LLMs will charge you on the basis of tokens. So can someone tell me, is every one word equal to one token?
Not really.
No, not necessarily.
Not necessarily, correct? So LLMs decide that. Okay. So LLMs decide that. So typically, one word, like for example, when I say trade-off, right? Trade can be one chunk, one token, ops can be one token, correct? So LLMs decide that typically the number of tokens is greater than number of words, okay, or equal to, greater than or equal to. So typically if I have 25,000 words in this, the number of tokens will be maybe 30,000, right? So you are basically sending a request of 30,000 tokens, okay, every time the user asks a question, correct? And every time you ask a question, user is also going to give LLM is also going to give a response. Maybe it's around 600 tokens, okay, because the response will be shorter. Now you as a system designer, solution designer should be aware of all this. You should know what is the chunk size that you're sending to the LLM every time, correct? You should also know, do I need 5 chunks every time, right? Do I need 5 chunks every time, or can you do it with just 3 chunks, correct? Do you need to send all 5 to it, or can you do it only 3 of them, correct? Now, that depends on what kind of data you have, right? If you have a very highly structured data, right, like this one, it's very structured, very neatly organized, maybe 3 can do. But again, that decision will be done based on how you analyze it in multiple iterations, correct? Because it's all decisions, right? So ultimately, like I said, you as an engineer will be valued for building a system which not only works, but also takes into aspect 3 factors. One is cost, right? Second is quality, correct? And third is latency. Okay, so these 3 are important from a person who is designing a system. Okay, so earlier on, it used to be that, these used to be taken care of by a lead architect, correct? Some architect, some big guy used to be sitting there. But now people who are engineers are expected to know this because that's the only differentiator, right? So you are expected to know this when somebody says, hey, you know what, user made 10 queries or 100 queries, and I'm already getting a bill of 70,000, right? Now, earlier we had maybe a customer say center where I could do it at 30,000. Now you're giving me a bill of 50,000. Why should I use the system? Correct? It makes no sense. So when the ball comes to your court in that situation, you cannot solve overnight. So you need to have these basics. Okay. So cost, quality, latency. Okay. So now if you look at these 3 aspects from this perspective, right? So the cost aspect is important from the tokens perspective. So you need to be clear what is the size of your chunks, correct? So if you use very large chunk size, obviously your cost is more. Okay. Now if you look at quality, will the quality improve if I have a large chunk size? Yeah.
Yes.
Yeah.
Quality is better, correct? Because LLM has more context, right? Ultimately, LLM more the context, the better for it, always, correct? And what about latency? Will it increase or decrease? Chunk size is more.
It will increase.
Increase.
It will decrease. Increase.
Decrease.
Decrease or increase?
Increase. Increase.
Increase.
Decrease.
Somebody saying decrease. You want to justify why decrease?
Because there are lesser chunks, so it takes lesser time to search.
Okay, so but you are talking about the search part of it. Okay, okay, you're saying you search isn't, that's also in a way valid, but lesser time to search. Okay, maybe we can buy that because it just searches few chunks and gets the results faster. But latency. Okay, for people who said increase, why increase?
Need to process all the tokens.
Who has
The
to
larger the chunk, the more that it will take time to embed it.
No, embedding is at the ingestion side, guys. Okay, so maybe I didn't talk about that. So this whole RAG process, right, it comes with 2 stages. One is called ingestion stage, right? and the other one is runtime. Okay, so if you look at it, ingestion is when you're actually doing all this PDF, chunks, vector embedding, storing vector embeddings, correct? This whole thing, what you're doing is at the ingestion phase. Okay, this whole thing. So if I were to put a color into that, right? This whole thing is ingestion, guys. Okay, the yellow one. Okay, now runtime is what is this one. Okay, so user query runs vector embeddings and runs. This is runtime. Okay, so ingestion is a one-time activity, so you don't do it daily, correct? So if it takes time to create chunks, it's not a big deal, correct? Because you are building a chatbot, user is not going to be worried whether you took 1 month to build it or 10 months to build it. User is going to be worried about what is the latency of the query they're asking. That should be fast. If you're taking 15 seconds to answer, nobody's going to use it. Okay. So with respect to latency, again, increase or decrease, it depends. If you look at one of the things, your network calls are going to rise. If you look at, right, your chunks of 5,000, this 25,000 words in your network, right? Every time you're sending this data, right, it goes out. So it kind of, again, LLM will take more time to process because it's taking more amount of data for processing, right? Because it has to, if the context is more, obviously it takes more time, right? You know it. If the context is less, it's faster. So definitely, I feel latency will increase.
Now that's significant.
It depends, right? See, the scale at which we generally operate, we don't realize. But if you're putting like, I'm just putting 25,000, if you put like 30, 40,000, it will definitely increase. You realize, right? It says analyzing. You look at Claude and you put a big file to it. It says sometimes it just immediately responds, sometimes it says thinking.
Because the file size, it takes.
Yes, it takes time, right? So because it has to analyze it, right? You cannot just give an answer. Now, if it's a small chunk size, let's look at this, guys. Cost, quality, latency. What is the impact, guys? What about cost? Is it increase or decrease? Cost.
It will decrease.
Okay, will decrease. Okay. And what about quality?
As the context is low, the quality decreases.
Correct, will decrease. Okay. And what about latency?
Obviously, it will decrease.
Yeah. Okay. So again, you are seeing that all of them are decreasing, but quality is important, guys. Okay. Quality is important. So it's a trade-off, right? Ultimately, it's a trade-off. So as engineers, you have to figure out what is it that your client wants or your company wants, right? Which one do they want to prioritize? So it is more of a trade-off. So you have to keep increasing, decreasing it, trying it out, trial and error a little bit to figure out what's the ideal chunk size, right? Where do you strike that sweet spot? Correct?
There are two things, right? One is the chunk size. Another thing is the number of chunks.
Yes.
Okay, both are important, right? Okay.
Now both are dependent, right? If you look at, if you have a chunk size of large chunk size, you'll have less chunks. It's inverse.
Yes.
Yeah.
Yeah. See, one is at the time of ingestion. Okay. So I think at the time of ingestion, see at the time of ingestion, the number of the chunk size that we give, it matters maybe for the pattern recognition of that part of it. Okay. Right. And at the time of querying, once the query we have submitted the query, so we have two controls here. One is the number of chunks. Okay.
Yeah.
Because chunk size is already determined, right? It's already input. Okay.
Yes.
So there we can have the control over number of chunks. Even though the chunk size is less, we can give more number of chunks. Okay, to be fed into the LLM, so that it can have a bigger context, and the accuracy of response can be made better. Okay, right.
See, to address your point, right? If you are trying to say that, hey, you know what, I will, whatever ingestion I did, but let me get more chunks and give them to the LLM so that I get a better output. What happens is your relevance score, right, keeps falling. So if you're saying, okay, I'm getting greedy profile, it's not that your quality will improve, because you will get more chunks, but the relevance of them will be low. So what's the point, right?
Yes.
So it's in fact hurting you more because your context is increasing, your tokens are increasing and at no extra benefit. Correct? The LLM is not going to be worried about how many you're going to send. It's going to take as many as you give. So you need to make that decision in terms of saying, does it make sense for me? Correct? So that's a call you have to take. Okay. So the other thing is, what I did not talk about so far is something called overlap. Okay. So what happens here, right? If I look at this document, right, and let's say I define my chunk size at say 2000. Okay. And let's say 2000 is from here, it starts all the way till here. Okay. So the Uruguayan triumph, it ends here. The next chunk starts from the first World Cup and all the way it goes till dominance. Okay. and then the next chunk starts from here. Again, it doesn't happen exactly like that, but let's say it does. Okay. So what happens is, let's say I ask a question about, tell me about the early years of Uruguayan triumph, correct? So what the vector DB will do is, since again, this is all one chunk, right? This whole thing is one chunk, right? It will return you this first chunk, okay? It will not return you perhaps the second chunk, right? Again, it might not, but it will say that this is the higher confidence, correct? Right? Because it has Uruguayan triumph and early years, everything in that, right? So what ends up happening is, if you keep each chunk exactly in tight buckets, right? Locked in tight buckets. So if you see, this is a bucket, no overlap, right? This one is ending here, next one is starting from here. In that case, what happens is, if you are getting a chunk, this one, right, and you pass this to the LLM, it's going to give you maybe insufficient kind of or irrelevant kind of information, correct? Or maybe it's not accurate enough, because the major details of this particular paragraph is here, correct? So this is the chunk which should have gone, ideally, correct? This is the chunk which should have gone, but semantic search says, this one makes sense, because that's how you beat a chunk, and the vector DB knows that. So what you have to do is make sure that there is an overlap across chunks, right? So you need to say, hey, you know what? Let me have this chunk from here to here, right? So basically the chunk size is 2000, fine, but with an overlap of say maybe 10%, 20%, whatever, so that each chunk will not only end here, but also take some more text till games, okay? Something like this. So what happens, the next chunk again will start from the first and end all the way till the stadium. So that even if I ask about post-war resurgence, when I get the second chunk still has some context about this, right? And it can give me some relevant information. So the other concept in RAG is chunk overlap. Okay, so chunk overlap is also an important decision you have to take. So chunk size is one thing, and chunk overlap, these are the two important decisions you need to make. Okay, and what are the other decisions we have to make? The other decision is also what LLM you take, correct? So what is LLM you're taking is also important. Okay, yeah, sorry, someone is saying something.
Yeah, see, what is the impact that chunk size and chunk overlap, okay, these values have on the vector value calculation?
Correct. So see, when you have chunk overlap, right, you will basically have the vector embeddings when they're created, right? So both those chunks will have similar text, correct? So if they have similar text, whenever I search for, let's say I want early years and Uruguayan triumph, I'll get both these chunks, right? The chunk which ends from here till here, and the other chunk which starts from maybe here and ends here, right? I'll get two chunks out, correct? So basically, again, it's all about trade-offs, right? The trade-off involved in having chunk overlap is greater context, right?
Yes.
That is a trade-off. You'll have greater context, right? So if you get greedy and say, you know what, let's have an 80% overlap, then you will have redundant overlapping code tokens or words, correct?
Yeah, if you have greater context, okay.
Yeah.
So we can get probably like a better vector relationship. Right?
Yes.
Right.
You'll get better accuracy in your results as well, but at the expense of cost. Okay.
Yeah.
Because you'll have two chunks now which will have the similar information. Now LLM is not going to complain, it's going to process it, it's happy it gets more, but you are making the cost increase, correct? So is that something you want? You'll have to decide, right? Okay, so chunk size, chunk overlap, and LLM, these are the three critical factors you need to consider. I'm not saying the vector DB is also an important thing. That, of course, if you look at the whole scheme of things, everything matters, right? So as you keep trying out, you'll get more details, right? Because some of them require more memory. Some DBs require more memory, some require less, and so on and so forth, correct? So, and the other thing is also whether you want to go again within LLMs, you have to again look at whether you look for open source LLMs or you looking for a closed source LLM, correct?
Yeah.
So this is important in the context of healthcare, where companies say, I don't want you to use closed source like Open ChatGPT or Gemini, right? Can you switch the door? Thank you. So in that case, you have to go for a closed open source, right? But if you want to go for an open source, you have to run it on your infrastructure, on your local or something using Olama. But not everybody can support it, and it's very expensive, right? So if you want to actually run these, you'll have to actually get a GPU, right? So does anybody know what it costs to rent a GPU? Typical, right? So I'll just show you how much it costs so that you get a perspective. So E2E Cloud is a company in India, right? Kind of rents.
Like they do have, the data centers in Delhi and Chennai, I guess, if I'm not wrong.
Yes. Yeah. They do
I
have,
moved that before.
yes. And I'll just show you the price. Okay. So, so these guys, where is this? Tensor core. Yeah, you can see here, right? H200 Tensor core GPUs, right? If you see, monthly billing itself is 2 lakhs, right? So if you go to the again the more advanced ones, they will be like 21 lakhs and so on and so forth, right? The H100s are like crazy, 16 lakhs. Okay, so it will be ridiculously expensive. You can't even afford to think of renting them. Of course, that's the challenge, right? Again, for using your own closed source. So that's why a lot of startups, what they do is they always go for open source, closed source. Sorry, if you want to use open source, it's very expensive. You need to have engineers who can manage them, and then the problem is you will hit it, and then the scalability becomes a challenge, right? You will keep hitting it, but it will not respond, right? So, and then what works very seamlessly for a ChatGPT or a Gemini will take like for eternity, correct? And you're trying to solve one problem, and you'll end up solving other problems. So that's also important. So vector database is also, again, you have a choice between closed source, open source, and stuff like that.
You will not have time and money to solve the core problem.
Exactly. You will not have the time and money to solve the core problem. You will be spending your time on other stuff, right? And
maybe over the years it may change.
yes, and then again, that's another thing. So that's why, again, nowadays everything is very powerful. APIs are very powerful, so people go for them. But again, if push comes to shove, if your client says you can't use open source, you can't. If you can't use closed source, you can't use. You have to figure out that. So in healthcare, this is a big problem. People think healthcare is a very fancy field to get into, but this is something that's real in healthcare. They don't want you to use closed source because it's all very confidential. So recently we did a hackathon for NephroPlus, so where they were looking for interns, right? So 2 interns, AI interns. So it was the same thing there, right? So they said they cannot use OpenAI or Gemini. So they were forced to use Olama and run the model in the local, in the hackathon itself. But, and as usual, machines can't support it. People were stuck, and, it was a mess all over, right? So, but of course, in a production environment, they will have powerful machines. But I'm just calling out NephroPlus is also a medical company, and they don't want the client's patient's data to move out. So healthcare looks nice and fancy, but just a reality check that these are some of the realities. So there's another company called Apex Cura in Hyderabad only, Apex Cura Healthcare. So I know the founder. He came and gave a session at one of our Build with AI sessions, right? So he talked about some of the challenges. So yeah, but anyway, that's diverging. Now coming to the next part of it. Any questions here before you move on?
There is also a question about which embedding model to choose.
Yeah.
And the dimension of the embedding model. Okay, because so they affect the precision also in a way, right?
Yeah.
So that's one thing. And how can you correlate this with with the chunk size? Okay.
Yeah.
Okay, so and how do we choose which embedding model, and how do we choose the dimension? Okay, same dimension doesn't mean same embedding value will be generated, right? Because these embedding models would have been trained on different training data set. Okay, so how do we link all these things?
Correct. So again, if we go that route, I think it's a separate discussion itself. So, but it's a valid point. I mentioned it here in terms of the decision making points, right? Vector embedding model and dimension also important. Okay, so we'll probably get there because I wanted to cover something more on the TableRAG, right? Because that's more of what we are talking today.
Sure.
Yeah. So let's get to the other problem that we have now. Let's look at this particular table. Okay, so this is the problem I want you guys to solve. We have a table here which calls about some match results. Okay, so which is spanning multiple pages, correct? So let's say it's multiple chunks. Okay, obviously, right? So if I'm saying a chunk size of say 200 or 300, let's say it starts from here and ends up on this page. Next chunk is from here to here. Next chunk is from here to here. A traditional query search will help me get the data, but the point is I want to be more analytical, right? I don't want to simply say, you know what, again, if I ask it, tell me about the early years at Irving and Trife, it will give me a nice answer, right? Which is not a big deal. But I want to be more analytical. I want to say, tell me about the 1978 World Cup, right? In terms of who were the players, right? In the group 1, right? And what were the scores for West Germany in home and away? Will it be able to answer this question? Anyone? You're seeing this data, right? I asked the question. Okay, I'll repeat the question. My question is, in 1978 World Cup, I want to understand how many were the home goals and away goals for Tunisia. Okay, so this is the column for home. This is a column for away. Okay. So if I ask this question, will it be able to answer anyone? Yes or no?
I'm not
Page.
sure, but
I think
feel
yes.
like
Yes, it will be able. Yes, it will be able to answer it.
Okay, I want to challenge you. How would it know? Because
Like I don't know. I have only overview because I have ran the project locally at one of the RAG. So during the embedding time, it was telling on the logs in the CLI log that no table found, zero table found.
correct. So the point is, see, when you convert this into vector embeddings, right, it's not a table anymore, right? So the context of a table, the context of a structured data goes out, correct? Because it's all stored in three-dimensional information. Now it will just have, okay, we asked about Scotland, Brazil, it might just dump something out on your face, but it may not be accurate, right? So the challenge that we are doing as part of this TableRAG, right? And this particular, I've shared this also with you guys in the chat, which I'm going to do. Where is this? Yeah. So I'm putting it again over here. Okay. So you people can open the repo, right? So the repo we built, which talks about this particular the solution for this problem. Okay. So there is also in this you can also find the high level architecture. Okay. So I'll just go through the high level architecture. Okay. So this is also there over here only. So this is the high level architecture. I'll show you the diagram. Okay. So the first problem is again for you, all of you, which I would like you to answer is how will you identify this table? Now I said this is the table, right? I want to make a query. Whatever query I want, you should be able to answer it. How do you think we should approach? Anybody? Because this table is in vector embeddings, I'm damn sure it might get, because another thing about this I'll tell you, there is no columns here, right? In this particular chunk that is there are no columns, correct? So when the chunk is also returned, let's say in whatever format it is returned, it would not have any details of the column. So how would the LLM be able to answer? Let's say this is the chunk that the vector DB returns. The LLM will have no context. It will not know which column is what, correct? So it might give you inaccurate information, correct? Right? So how will you, anybody, any thoughts? How can we solve this?
Can you put in a traditional database and then?
But how will you put it in your traditional database?
Have a call out to that.
How will you put it in a traditional database?
Use OCR.
No, this is a PDF. You don't need to OCR, right? OCR is too heavy for this. It's just a PDF. So don't use over engineering, right? When you can do it simpler manner, correct? Right? Again, OCR will require you, it is cost you more, right? I know you have TesseraCT and all that, but again, you don't want to complicate. Okay, I'll tell the solution. So the solution is, like I said, there is an ingestion phase and there's a runtime phase, correct? Now at ingestion phase, what we do is we pull out the entire data from this file, this PDF file, and we segregate it using Python libraries into what is text and what is tables. Okay, that we can do, right? So out of this entire PDF file, what I showed you, it is clear that until here, this is all text, correct? This is all text. And after this is all table. So what I will do is I will take all this text and send it to the vector embeddings into the Pinecone vector database. Whatever is there after that, this whole table, I'll put it into MySQL. Okay. But the challenge is to put it into MySQL. MySQL is a relational database. It will say, I cannot store data without you telling me the schema. Correct? Right? So then how will we store? Anyone? So we solved one problem where we separate the text and the table. But now I want to store the table data in MySQL. But how do we store it?
I mean, a wild guess, but
Do we have to use another database, NoSQL?
you can
No.
can just
Even to
ask
store
a-
it into NoSQL, you need the schema, right? Yeah.
You can just ask a ChatGPT
You meant to say schema on right kind?
to the SQL to kind
Yeah.
of generate it, right?
Yes. Yeah, you need a schema, right? Even in a NoSQL database, you need a schema, right? You can't just store it,
Yeah.
right? I can't just dump it, right? Of course, you can take a JSON and dump it, but then you still need to define this is the key and that is the value, right? That's how we need to. So one way how we can do it is give it to the ChatGPT, correct? Give it this whole table. Don't give the entire table. Give this table with the first 5 columns. All the columns with the first 5 rows. That's enough for it to understand the context. So it's smart enough to understand that this particular table has these columns, these 5 rows, and what are the key values it should contain, and it will store it for you. Sounds good? Yeah. So if you do that much, it will define schema, and you take that schema and you create the schema in MySQL. It will create the queries for all of this data, correct? And take those queries and insert them. Cool. So in fact, what I'll do is I'll just share. I'll share this schema with you. Okay, I'll probably take a. Okay, again, I need to connect from another system. I don't think we have time for that. Like, let me do one thing. Let me just see if I can open this. What is the link for this? Yeah, I wanted to show you the MySQL database, how where it's stored. Okay, let me just open it. It is RNN hyphen. Yeah. So yeah. Can you see my screen now? Yeah, thumbs up, please.
Yes.
Can you see my screen? Yeah. Thumbs up, please. Okay. So you guys can see my screen here. This is the MySQL, right? So this is that PDF file which I got it into MySQL. Okay. So this is how it's created. So it says PDF underscore so and so World Cup matches. This is how it converts all of the data into text. Right. All the data is converted into this table. Match underscore ready year round here team away teams home score away score winner. So convert it into this format. Okay. Cool. Show is yeah. So now that we have the data in the MySQL, right? The next challenge is for all of you. Can you hear me? Hello. Yeah, I'm just switching laptops. Okay, so you can you hear me? Yeah. Okay. Good. So the next challenge for all of you is now that we have the data, right? So when you ask a query, how does it work? Let's say I ask a query, and in fact, I will show you guys in the actual chatbot itself. So I ping this chatbot right with this is the actual app, and all of you can also use and try it out. You can upload your own documents also. So if I open this particular chatbot, I will upload this document also in front of you. In fact, you can also try it out yourself. So it runs on render, guys. Okay, the backend runs on render, so it might be a little bit of a delay. But anyway, you guys can check it out. So if you ask a question saying, show me about, what happened to the Tunisia, how many runs did Tunisia get in the home match in 78, it'll give you a response. Okay. And in the interest of time, I'm not uploading it now, but you guys can run it. One second, the FIFA World Cup. Let me see if I can run it. So this is publicly available. Okay, this one is the file, guys. So let's run it and see it. Anyways, I'm uploading it now. You can click on the upload, and it'll just upload. If you're seeing balloons, means it's successfully run. So let's see. I hope it works. So typically, when it's in production and in front of a client demo, that's when it stops working. But I hope it works. So you guys can try it yourself. So whatever you upload, right, your document is only in that context. The search will happen only in the context of that PDF. Okay. So we designed in such a way because my vector embedding should not interfere with yours, right? So, okay. So one question I have for you guys, okay, and this is a question I ask. Let's say the data is corrupted in this file, okay. So let's say this particular data is inaccurate. It's not 1974, but it's actually 1976, okay, or 1978. What will you guys do? How will you kind of fix it while it's uploading? Anyone? Let's say my PDF is corrupt and somebody corrected it and gave to me, Vijender, see, what is not 1974, it's 1979, let's say, whatever, right? What will you do?
In upload document which is addendum, I mean, whatever, errata.
So now you'll have the vector embeddings of the previous file and the new file, but the corrected data will already be there, right? So use the searches for it, that will come. Hey guys, I think we got it. Okay, so the data has been loaded. So let's just see if it works. Okay, I don't know. Let's see. Let's ask. Tell me about let's see if you say hi, it should always respond. If it responds, means it's working. Yeah, okay, it's working. That's good. Let's just ask some question, right? Tell me about the first World Cup. Okay, so let's see what it gives back. So it should say the first World Cup was held in Uruguay. I hope it works. Let's see. So again, all of this is running in on the free task guide, so that's why it's going to take time. But again, is this acceptable? Not acceptable, right? It shouldn't take so long. It should be faster. Okay, I think the request itself took too long. Okay, so the first. Where's the first World Cup? Oh, sorry, I said. Yeah. So again, you guys can try it out again in the interest of time. We have another meeting as well. So the thing is, how does this work? Is basically the user's query, right? Whatever is user is asking, it goes, it goes and we built the solution using LangGraph. Okay, so LangGraph is an agent framework to build agents. So this one has 3 nodes. So LangGraph has nodes, which is the manager node, and you have the table node, and you have the RAG node. Okay, so what the LangGraph does is the request when it comes from the user, it goes to the manager node first. Manager node decides what is the user asking. Is he asking only text query or only data query or table or hybrid, right? So it decides if it is user saying a generic query like what I am asking right now. It's a generic query, right? Hey, look at this. Okay, I think this one is working. So this is a query I asked before, guys. In all the matches played by Tunisia as home team, count the final score. So result is 3. Okay, tell me the years when Tunisia played as a home team. 1978, correct? So if you see the PDF in the last, right, it will give you that exact answer, right? Tunisia played in 1978 only, correct? If you look at it. And tell me the years when Brazil played as a home team. Now, if you see home team is this column, and Brazil is all these, right? So you'll find that where Brazil played as a home team are these years, okay, which is pretty much accurate, okay. You guys can check it offline, I think, in the interest of time. So what I wanted to kind of call out in the next 2 minutes is the user query goes, right, when the user asks a query, it goes to the manager node. Manager node has is an AI agent which decides if the user asks a text or a data query or a combination, and it sends to the respective nodes, and these nodes return the response back to the manager. Manager returns the response. Okay. Now, how does the RAG is straightforward, right? If it's only text, RAG can easily solve it and get it back. But if it is table, right? Like the question I asked here is a table query, correct? Like for example, I said in show me the away teams, or I said tell me the years when Brazil played as a home team, correct? This is a data query, correct? So how does the manager node know, correct, that it is a text or a table, correct? Because it's looking at this query for the first time, correct? So it knows it because we send the schema of all the tables to the manager node, right? The schema which is defined at ingestion time, right? At ingestion time only we define the schema, right? We send the schema, we send the user query, and the manager node makes a decision. Okay, based on the tables and the data which is there, I think this is a table query or a RAG query, and then it will appropriately route it, get the results, collate them, return to the user. Cool, and that's how it's working. Okay.
So does one have a precedence over the other? Like the table has a precedence over, is that usually how it is?
It depends. That also manager takes a call.
You could.
Manager will take a call.
Okay.
Right? Should it be that I first get the data, collate it, and then pass it on to the RAG, or should I take one after the other? It takes a decision because they're smart enough, right? So that's where the agentic AI, ecosystem comes. Agents versus agentic AI, that's the difference. Agentic AI is all about understanding and doing multiple things in a stepwise manner through a decision-making process, correct? So this is a good example of that. And this code has all that, guys. You can run it on your local and try it out, okay? But pretty much this is what it is. I think we're running short on time. But if anybody has any questions, we can take maybe a question or two.
For querying the table, are we using text to SQL generation?
Yes, no, we are, yeah, the LLM directly generates the query here. You know, this table agent, which is there, right? It looks at the query and it has a schema, right? Then it creates the query, which we dynamically hit the MySQL and get the response.
Got it.
Got it?
And sir, I was actually a bit late to the class. Can I have the flowchart diagram that you have made here, so like I can understand the flow?
No problem. I'll do that. I'll share this recording as well.
Please.
Yeah, and I'll put this document as well in that. Okay.
Yeah, thank you so much.
I'll put it in this README file. You can check out this README file. Okay. Yeah. Okay. So I hope it was useful. Okay. So again,
the question you asked, how do we change the corrupted data? Like,
yeah. Corrupted data.
is it through the metadata that we store, like both backtrack through the document?
Yeah. So there are two strategies, right? So like I said, one is brute force, another one is optimal, correct? Brute force way is just flush out the entire vector embeddings and reload it for the document, correct?
That would be,
yeah, that is the foolproof way, safe way. But the challenge with that is most of the times, right, when you're ingesting, it's not directly a single process where you just create chunks and load it, right? Because there might be a human in the loop also involved sometimes, because in the type of ingestion, you're creating these SQL, all these SQL queries and all these tables also, right? So it's possible that it may not be accurate. So you need to have a human in the loop who says, okay, this is all good to go, or does it require further iterations, correct? So it can be an expensive process and time-consuming process. So the brute force manner of saying, okay, flush everything and reload can be expensive and time-consuming. So the optimal way is every chunk is stored in the vector database as a metadata, right? The chunk is stored, the ID is stored, and the embeddings are stored. So what you need to do is you need to figure out which chunk holds this corrupted data and replace that chunk. Got it? So only that chunk you should replace it. Now, how will you know which chunk to replace it? Because you know you have access to the vector database, correct? So you can go in and you can directly get that chunk afresh and then convert it into embeddings and store it again. Got it? So you can selectively clear one or two, or because there's overlap, right? Now you can't remove only one chunk, there'll be overlap. So you need to figure out where is the corrupted data stored in which chunks in the database, purge them and embed them again and store them back.